let's get started on section P6. Okay, so this is talking about rational expressions. We're going to talk about domains and simplifying expressions. Okay, so a rational expression is just the quotient of two polynomials. All right, here's an example of that. So you just have one polynomial over another one, no big deal. And the set of all numbers for which a function is defined is called the domain. Okay, so we like to say when a function is undefined is whenever we would get something like x plus 3 over 0. Anything over 0, right? That's not good. That's undefined. Okay. And the set of all numbers for which a function is defined is called the domain. So we must exclude any number from the domain if it makes our denominator equal to 0, because that's bad. Okay. We need to exclude those numbers. Okay. So look at these two examples. Okay, it says find all the numbers that must be excluded from the domain of the functions. Okay, here's our first one. All right, and all we're going to do is we're going to set denominator equal to 0 and exclude. Okay. All right, so x plus 5 is our denominator, set it equal to 0. And we're going to want to solve for x. So we're going to subtract 5, no big deal. And x equals -5. So what that says is that if we plugged in -5 for x in our denominator, we would get 0. And of course we would. -5 plus 5 equals 0. So when x equals -5, we have an issue. Okay, so that's not going to be in our domain. So -5 is not in our domain. Okay. All right. Let's look at this one. Again, we're just going to set our denominator equal to 0 and exclude. Okay, so our denominator is x squared minus 36 equals 0. Okay, well, now we have a quadratic. Okay, over here we had just a linear, right? We just subtracted 5 and we were good. Here, we need to factor this guy. Okay, so you notice that this is the difference of squares, right? X squared minus 36. So we have the square root of 36 is 6. The square root of x squared is x, of course. Okay, so we get x plus 6, x minus 6 equal to 0. Now we just set both of our sets of parentheses equal to 0 and solve. Okay, so subtract 6 here, x equals -6, add 6 here, and x equals +6. So what this means is that if I plugged in 6 or -6, I would get 0 in my denominator, which is good. So the only difference between these two examples is that this one we only had to exclude one number, and this one we had to exclude two numbers. Okay. So -6 and 6 are not in our domain. -6 and 6 are not in the domain. Okay. So main thing to remember about domains is that you're going to set your denominator equal to 0 and you're going to exclude, and those numbers that you get are numbers that you can't have for x, because that makes the denominator equal to 0, which makes it undefined. And we only want defined. Okay. Okay, we can also simplify these fractions. Okay. When you are simplifying fractions, you should factor completely and then reduce. Okay, so factor completely. All right, that's what we did in section P5, right? So we're just going to factor completely like we know how to do, and then reduce. All right, so just take it one numerator and one denominator at a time. Okay, so x cubed plus 3x squared. Okay, well, there's only one thing that we can do to the numerator to factor it, and that's take out the greatest common factor of 3x squared. Okay, I can take out, nope, I can only take out an x squared. I can take out an x squared. That's the only thing that those two terms have in common is an x squared. And I'm left with x plus 3. Okay. There's nothing I can do to x plus 3. I can't factor that anymore. So I'm just going to leave it as x plus 3. Now, we get to reduce everything that they have in common. Okay, exactly what they have in common is an x plus 3 and an x plus 3. So all we're left with is x squared. So we reduced in the purple. Okay, and this is our answer. Okay, so that is just simplifying. I gave you a rational expression and I said, hey, simplify it. That is when you are going to factor completely and then reduce. Okay, now look at this. Now we're going to multiply and simplify. So whenever we multiply two rational expressions together, multiplying and dividing fractions, just regular fractions, is much easier than adding and subtracting them because we don't have to find that common denominator, right? We just multiply straight across the top, straight across the bottom, okay? Because of that, we're going to take each numerator and each denominator and factor it completely, okay? And then we're just going to simplify, just like we did in the problem above it, where we just marked out whatever we had in common, okay? So let's take it one numerator and denominator at a time, all right? So x plus 3, nothing we can do there, okay? X squared minus 4, that denominator, okay? That's the difference of squares, okay? So x plus 2, x minus 2, okay? And I got that by saying the square root of x squared is x, the square root of 4 is 2. Okay, so those go here and here. One gets a plus, one gets a minus, and we're done. All right. We're multiplying it by this other rational expression. So let's do the numerator of this guy. Okay, well, this is an easy trinomial. Okay, that's what we name it because of that first term, right? The first term doesn't have a coefficient on the x squared term, so we label that an easy trinomial, okay? So we have an x and an x. Our signs are different in our parentheses, so we give a plus and a minus. And now we need the factors of 6 that add to give us -1. Okay, I'm getting that from right here. The factors of 6 that add to give us -1. Okay, well, the only factors of 6 are 6 and 1 and 3 and 2. Okay, so we're going to use 3 and 2, and we need our middle term to be negative. So we're going to give the bigger number, which is 3, the negative. And we're going to give 2 the positive number. Okay, and remember that you can always check yourself by saying 2x minus 3x gives you -1x. That's exactly, where is it, what you want. Okay, you can always do that. So now let's do the bottom. Okay, that's another easy trinomial. And we have x and x. Our signs are the same, and they're both positive. So I can go ahead and fill that in. Now I need the factors of 9 that add to give me +6. Okay, and I'm going to get x plus 3, x plus 3. Okay, and I can always check myself. 3x gives me 6x, and I'm good. Okay, so now that's all the work. Okay, we've done the work. Now we just need to cross out. Okay, we need to match some things up. You can cross them out. Whoops. diagonally, okay? They don't have to be over the same bar because we're multiplying. So if we wanted to write this over one bar, we absolutely could, because we're just going to multiply across the top and across the bottom anyway, right? That's what we do when we multiply, okay? So we can cross out diagonally too. It doesn't just have to be over the same bar. So I have an x plus 2 here and an x plus 2 there. I have an x plus 3 and an x plus 3, okay? That's all I can cross out. So I'm going to write what I have left. I have x minus 3 only left up top, right? And I have x minus 2 times x plus 3 left in the bottom. And that's my answer, okay? That is how you multiply and simplify, okay? Now, if we can simplify and then multiply and simplify, then we can also divide and simplify, okay? Division is also going to be easier than addition and subtraction, okay? But there's one little thing that we need to do whenever we divide, okay? And it's probably going to sound similar, okay? We are going to need to keep, change, flip, okay? You've probably heard of that, right? And what do I mean? What are we keeping, changing, and flipping? We're going to keep the first fraction the same. So x squared minus 2x plus 1 over x cubed plus x. That's going to stay the same. We're going to keep it the same, hence why we say keep, okay? We're going to change our division sign to multiplication. And then we're going to flip the second fraction. So numerator becomes denominator, denominator becomes numerator. So we just have 3x squared plus 3 over x squared plus x minus 2, okay? Keep, change, flip. So after we keep, change, and flip, well, now we just have a multiplication problem, okay? And that's what we just did. So we're just going to do what we did in the last problem. We're going to factor each numerator and each denominator and then simplify, okay? Then cross out. So let's do the first numerator, and I'll do it like this, okay? We would label that an easy trinomial, okay? This guy. So I know I have an x and an x. I know that both of my signs are the same and that they are both negative. So minus and minus. And I need the factors of 1 that add to give me 2. I only have one option, and that's 1 and 1. Okay, so that one was not bad. The denominator, we have 2 terms. So we're either going to do the difference of squares or the difference of cubes. That's the only strategy that I taught you with 2 terms, right? And I can't do either of those. Neither of those look like something that I can deal with, okay? So the only other thing that I have left to do is just, can I take out something that they both have in common? They both have an x in common, and I'm left with x squared plus 1, okay? Times. Same thing with that numerator. I can just take out a 3, and I'm left with x squared plus 1. And then I have another easy trinomial in my denominator, x and x. My signs are different, and I need my middle term to be positive. So I know that I'm going to have a plus and a minus. And I need the factors of 2 that add to give me 1. Well, the only factors of 2 are 2 and 1. But I need a positive x, so I'm going to give my bigger number, which is 2, the positive, and my 1 the negative. You can always check it. Remember, 2x minus 1x gives you positive 1x, which is what you want, okay? Now you can cross out. So we have x squared plus 1, x squared plus 1, x minus 1, and then x minus 1, okay? Doesn't matter which x minus 1 you cross out there. You could have done this one and kept this one. It doesn't matter, Okay, so now we got to see what we're left with. We're left with 3 times x minus 1 over x times x plus, plus 2. Okay. That is how we simplify, multiply and simplify, and divide and simplify. Okay.